Everyone, welcome to my channel again. So today we will discuss one problem in Leetcode, that is 845, longest mountain in array. So what is the problem statement is saying? So you will be given one array, okay. Then you have to represent one mountain out of it. That means individual number will present some height. 2, 1, 4, 7, 3, 2, 4. Now you have to tell which one is the largest mountain in lengthwise. Now the definition of mountain here is which will go up and come down. That will be a proper mountain. So in this case from 2 to 1 it is going down only, it is not going up. So this part is not a proper mountain. Only proper mountain in this picture is from 1 it is going up, then it is coming down and coming down, right? So from 1 to 2 it is forming a proper mountain. 2 to 4 also it is not a mountain. And one more thing to discuss here is, if suppose it is going up, then one point they are same, then it is coming down, that will also not be considered as a mountain. So in this case the length of the mountain, the maximum length of the mountain will be from 1 to 2, which is 5. Let's take another example and understand it more. So there is an array from 0 to 4, 1, and it is forming still 1. So here I can see that properly 3 mountain actually is formed. So the first mountain here is from 0 to 1, and the length of the mountain is 4, 0 to 4, 1. Then another proper mountain is this one. This is going up, going up, going up, and it is coming down. Okay, so from 1 to 2 it is forming another mountain with the length of 7. Then from here it is going up, then coming down and coming down. Okay, so this is also a proper mountain in this case, and the length of the mountain is 6. So our answer will be 7, because this is the mountain which has the highest length. Now we will check how to solve this problem. Now we have to check how we can solve this problem. So what brute force solution is coming in our mind? The brute force solution is, we have to find some portion from this array where first it is going up and then it is coming down. So that will be our mountain. So to achieve that thing, what we can do is, from the starting we can check for that condition. Means from starting we can fix our start position, and then we can take help of another pointer which will be suppose end. So that end we will move if we get something similar, which is means first it is going up, then it is coming down. So we will take help of 2 pointers here. One is start and another one is end. And then somewhere we have to store the maximum length, because suppose this is one mountain, if we got the length as 3, and next time if we got a bigger mountain which has length as 6, then we have to update that number. So that number we can keep in a variable called max. Okay. Now while proceeding, few rules we have to follow. The rules are, if my current position is less than the right position, then we will move the end forward. That means suppose to form a mountain we have to check if my right side value is less than my current position or not. If that is the case, then we have to move forward. Go ahead. Then after some point, if my current position is greater than right, means it is going down, then also we have to move the end. But this condition only we have to check if first condition arises. Now we have to move the end till it is again going up, and in that case we have to update the max value. The max value will be the end minus start, right? Means if we fix the start here and end is going on, where actually it will end minus start we will do. And then at last we have to move the start. Means if we get a mountain here, then we have to move the start here to check from this point of towards. So in that case we will check the max value of end or start plus 1, because if we don't found any mountain we will just move one step. Okay, so now if we check here and go through this array, it will be more clear. So initially start and end will be in the same position. So to denote start, I will use this symbol, and for end this symbol. Okay, so initially start is here and end is also here. Now we have to check if my current is less than my right or not. So here the right is 3. Okay, that means current is actually bigger than the right. That means we don't have to enter 1 2 3. No condition is satisfying here in this case. So we have to do the fourth step, that is max of end or start plus 1. So start plus 1 will be 1 and end is 0 now. That means we have to choose the start plus 1. So my start will move here. Okay, and obviously always like start and end is same, that's why we have to move the end also. The next step also, the right side, it is actually less than the current. So in the same condition is happening here also. So in this case also we have to move start and end. Next what is happening here, the right side is bigger. From 2 to 3 if we have to jump, then right side is bigger. That's why we have to move the end and we have to fix the start here. Then what we can see is next the start means the current position is equal to the right side. That means we don't have to move it. Okay, so in that condition other things are not satisfying, so we have to move the start here. Then in similar fashion here also right side I can't move, so that's why my start and end will be same. Then this slope also is similar to this slope, means we will not get any condition to be satisfied here. So gradually we have to move both. Now from this point what we can see is my right side is bigger than my current, so we have to move the end. Then also my right side is bigger than my left or current, so we have to move the end. Then right side actually is bigger than my current, so we have to again move the end. Then this part is done. Then what we can see is my current is now actually greater than right. That means it is going down, so we have to move forward the end. Here also it is satisfying, so we will move the end. Here also it is satisfying, so we will move the end. Here also it is satisfying, so we will move the end. But here it is not satisfying. That means we have to stop. Now my end is here and my start was here, right? So the maximum difference what we will get here is from like 13 to 6. Okay, means 1 2 3 4 5 6 7 8. So maximum 8 we got as a result, because it is a valid mountain here. Now after that what we will do is, which one is greater? My end is actually 13 now and my start plus 1 is 6 plus 1, that is 7. Which one is greater? 13 is greater, right? So we have to move my start here. Now we have to again check that current is less than right or not. Yes, current is less than my right, so we have to move the end. But after that what we can check is right side nothing is there. That means this condition is not satisfying. So what we can do is, it is not a mountain we got to know, so we will not update the max value. So we will do a comparison, like start is maximum of end or start plus 1. So the start plus 1 is 14 and the end is also 14. So in this case we will choose the start from here. Then it is end of the array, means we don't have to move forward. So the answer is 8 in this case. So few things to consider here is, always check if the current value is less than my right side, then only do the other part of the thing, or else simply move the start. So now we will do the programming and things will be more clear. Now let's start with the coding part. So initially few variables I will define. First we will check the length. Okay, length has an important role to play here, because we have to check that we are before end of the array or not. And then to storing the answer we will take one variable called max, and we will define two variable. One is start, which will be initialized to 0, and then end, which will be also 0. So we have to proceed this operation until my start will be always less than the n, means the length of the array. So while the start is less than n, till then we have to proceed. Now first we have to check that my current position is the left side boundary or not. Means if first I have to check, like if end plus 1 means where actually end will start, that is plus 1 is less than n or not, means otherwise it will out of bound exception we will get. And then we have to check if this array position of end actually is less than array position of end plus 1 or not, means my right side value is greater than me or not. If that is the case, that means this is the base of the left side base actually for the mountain to go upwards. Then we have to go upwards till we reach to the peak. So while same condition will appear, while same condition is there, we will move the end, means we will do a end plus plus, and every time in the starting we will do our end equal to start. Now next what you have to do is, inside this if condition only, if it is reaches to the top, we have to check that it is going down or not. Then the same condition only we have to paste here also, with slight modification. That will be, in this case it will be greater than, means it is going down or not we will check, and this will also be greater than. And for same condition we will do a end plus plus. Now after it reaches to the right side like bottom actually, then we have to update the result. So our max will be we have to update max.max equal to the previous max and the result for this mountain. So the length of this mountain will be end minus start plus 1, right? So it will update the value if it is greater than. Then here actually after the if condition, so we have to move the start. So if it is a valid mountain, then my end will be my new start, and if it is not a valid mountain, just we have to move the start to start plus 1. So how to determine that? So my new start will be the maximum of both, means either it will be the end or it will be start plus 1. Okay, so now at the end we have to return the max as a result. Let's just compile it. Now submit. Yeah, it is working. Thanks for watching.